Hi everyone. There's like no one here yet, but for all the people that watch in the future, hello. Okay, I think this is working. Alright. Hi, my name is Gabrielle, and we are doing a live chat today about plankton and about oceanography and all kinds of stuff. So for those of you hello that are just starting to join, hi, and so this will probably just kind of happen organically. I have close to 20 questions that were submitted, which is pretty exciting, so thank you guys so much for submitting some awesome questions, but I'm not expecting too many people since it is pretty early in the morning on a Sunday. So I'm just going to introduce a little bit about what I do, my background, and then talk a lot about just oceanography and plankton and what it means to be a marine scientist. So I'm Gabrielle. Some of you guys may know me from March of the Plankton. That's my Instagram handle. And I study plankton. I study some of the smallest organisms in the ocean. Specifically, I work on Nano Flageolets, which is a group of plankton. And I work in North Carolina right now. So I'm from originally Connecticut, and I'm down here getting my PhD. I'm in my 4th year, and I'm a PhD candidate. So I am here for probably another year, maybe a little bit less, maybe 10 months or so, until I defend. So that's a little bit about my background. I'm an ecologist, and I love studying behavior. Behavior is one of my favorite things to talk about and to read about. And there's a surprising bit of diversity of behavior in plankton. So that's a little bit about me. And a lot of people ask me in the questions that they submitted, well, what are plankton, or why do we care about plankton? What is their importance? So I guess we can kind of just jump right in and talk about why there are scientists in the world that study plankton. So plankton is a lifestyle, which is the title of this talk. And so plankton is just a lifestyle. So if you can't swim against the current, if you're an organism that can't swim against the current, you're plankton. So things like larval fish, larval mollusks, you have larger organisms that are planktonic through part of their lives, jellyfish are plankton. And you have the more traditional thought of plankton, like the phytoplankton, like the diatoms, the dinoflagellates, things like this. So I have some images that I usually share with my students. I'm just going to share with you. I printed them out a while ago, just so you guys can get an idea of what plankton are. So you have things like copepods and nauplii of copepods, as well as barnacles. You also have things like worms. And it's pretty cool. There's a huge diversity of plankton. This is zooplankton specifically. And so again, things like jellyfish, mollusk larval stages, fish larvae as well. So all these organisms can't swim against the current. Maybe their adult forms can, but at some point they are planktonic, so they're considered to be plankton. So some common examples of plankton that I normally get asked quite a bit about are things like dinoflagellates. So if you guys live in an area where the water will actually light up at night, and these are usually due to dinoflagellates. So these organisms have 2 different flagella, and they use that to move throughout the water column ever so slightly. So if you're in Puerto Rico or different parts of Hawaii, you will be able to see the bioluminescence at night, and that's from usually the dinoflagellates. So if you guys are in freshwater systems, maybe you've seen paramecium. These are also just a freshwater plankton, because plankton can be anywhere. They can be in freshwater, estuary, brackish, marine. They can be in hypersaline systems as well. So they're pretty fascinating. And whether it be zooplankton or phytoplankton, they're there. Deep ocean, surface waters. Plankton incorporate things also like bacteria and viruses. So it's really interesting, and when you start to think about all the diversity of plankton, it's pretty mind-boggling. For things like viruses, I got asked about viruses, and one of the questions, think about how many viruses. You have millions of viruses just in a teaspoon of water. So each time that you go into the ocean and you're swallowing a mouthful of water, think of the millions of organisms that you just swallowed by accident. And those are all different types of plankton. So it's pretty interesting. Yeah, so that's a little bit about what plankton are. That's probably one of the biggest misconceptions that I get as a plankton scientist and as an oceanographer. I get, well, plankton are really tiny and they don't incorporate anything else. Well, some of them are, for sure, but plankton is just a lifestyle. So if you come away with anything from this talk, just remember, if you can't swim against the current, you are a plankton. So it's just a lifestyle. So those are the first few questions I got asked, and I got asked a lot about what about their importance of plankton, like why do we care about them? And I bet a lot of you guys know this answer already, but plankton are the base of the food web in the marine system as well as in freshwater systems as well. So if you think about how important grasses are to terrestrial systems, that is the same purpose and the same importance of plankton. So plankton are they have a huge impact, they're incredibly important. They really will stabilize the marine system when you're thinking about how temperature or a lot of high eutrophic or low eutrophic conditions are going to impact plankton. That's going to impact and that's going to go up the food web as well. So plankton are the base of the food web, and additionally, they provide a huge amount of oxygen to our system. Everyone thinks that it's trees, and yeah, so trees do contribute a bit. It's usually 50-50. But plankton are really the tried and true organisms here. They are, 70% or higher of our globe is covered by water, covered by the ocean, and you can find plankton in all of these areas, and they are contributing 50% of our oxygen. So those are the two main things, stability of ecosystem as well as the contributions to the atmosphere. Those are the two biggest components of plankton. They're also important when you think about fisheries. Fisheries are huge, not just in the United States, but essentially any coastal area is dependent on plankton stability as well as non-toxic species in the balance of the fisheries. So if you eat fish, or if you're reliant on fish as your main protein source, or if you eat a lot of bivalves, things like this, those are all going to be impacted by plankton. So do you guys have any questions so far? I've been throwing a lot of information at you, so I know I have a few people here. Do you guys have any questions right now before I move on about plankton or their importance or their diversity? Okay. Hello for the few people that are here. Hi. Okay, so I'm just going to continue to go through some of these questions. One of the other questions I got asked quite a bit is about climate change and pollution and that impact with plankton as well. So I guess the biggest thing to think about, because we talked about plankton diversity and all the different types of plankton. We talked about their importance on the global scale. And if you think about how the changing ocean temperature as well as acidification is happening, that's going to impact a few different groups of plankton quite a bit. So this image here, these are coccoliths, and these are pretty important plankton. They are going to have calcium carbonate shells. And when you guys can see here, a lot of them will have scales, and these scales are made of calcium carbonate. They're so impactful, you can actually see them from space. When they form these large plankton blooms, you can see these particular groups from space. And they have a huge impact on the global system when you're talking about as prey items, but also as they sink throughout the water column, they're actually taking that organic matter down to the depths of the ocean. Now, with ocean acidification happening, the calcium carbonate shells that these organisms have are being impacted by the change of pH in the ocean. And that's all from the increase of CO2 in the atmosphere and things like this. So that's probably one of the main ways when you're thinking about larval mollusks, when you're thinking about coccolithophores, when you're thinking about a lot of different larval sea urchins and echinoderms and things like this, you're going to be impacted by that ocean acidification and by that temperature change. That's probably one of the more obvious examples that I normally tell students or things with outreach and things like that. When you have an impact on a global scale, you're going to see a global impact. It's really just that simple. You're going to see it on a regional level by what pollution you put into the atmosphere, whether it be nitrates or different forms of fertilizers from farming. You're going to see plankton blooms. You're going to see changes on a local level, primarily through dead zones as well. We see that in the southern part of the United States, see a lot of dead zones. So these are common things I'm sure a lot of you guys have heard when you're thinking about ocean science and you're thinking about just marine science with plankton in general. Hello for the new people that just arrived. Hi. So in regards to pollution, I'm sure a lot of you guys have heard of microplastics. And I get asked about this quite a bit, about microplastics, because microplastics fit in the same scale range as plankton, right? And so a lot of planktivores, a lot of organisms that eat plankton are also consuming microplastics. So microplastics are a huge part now, unfortunately, of the surface water, and they are they're very much being incorporated into that system. So a lot of planktivores, so like things like anchovies and smaller bait fish are consuming the plankton, and are then consuming the microplastics. So it's very common to see them. I normally see about 1 or 2 pieces of microplastics per maybe 5 mils or so when I do plankton tows just out in North Carolina. They're not incredibly common. They're not, in every single mill that I have, but probably every 5 mils I'll see like 1 or 2 pieces of microplastic. So it's pretty common. I'm probably going to do a post on my Instagram on March of the Plankton. I'll probably do that and just give some examples of microplastics that we see. A lot of it is from old fishing gear that's just been broken down over the years, and so if you leave your older plastic traps or fishing line or things like that that are around, that will break down, as well as plastic containers. So things like water bottles, soda bottles, food containers, those break down. Those are probably the two more common things that I see being broken down from into microplastics. So those are some examples. And hopefully you guys know a lot about, wherever you guys are from, whether you're from the southeast part of the United States or, a different part of the United States or international. Hopefully there has been at least a little bit of a push for the minimization of plastic use. That's probably one of the larger things that can help reduce the microplastics in the plankton system, in the microbial loop that we see in the ocean. So do you guys have any questions so far? Feel free to ask them. Hello to the new people. Hello, hi. So if you guys have any questions about anything that I've covered, please feel free to ask. I will do my best to answer them. Okay, so we have a few more questions. How did you get into plankton research and why? So one of the biggest things that I was interested in with plankton research, aside from the impact of pollution, which was always kind of in the back of my mind. I was a huge person in college for reduce, reuse, recycle, and just making sure that is well received on campus and understanding what that means for marine organisms. But I got into plankton primarily because I'm a question-based scientist. So I ask all scientific questions that are kind of based on a system that are less based on an organism, and my questions usually are related to behavior. And the professor that I decided to contact for my PhD, she did plankton research, and I had done a little bit of work with plankton, freshwater plankton. I did research at Yale for a little while, and while I was at Yale, I worked with paramecium and a few different types of freshwater organisms, and I was interested in understanding a little bit more of what that meant for marine systems. So it's kind of how I ended up here. A lot of it had to do with my advisor, who is pretty awesome, and she helped guide me into what I'm doing now, which is a little bit of taxonomy, a little bit of molecular biology, and a little bit of ecology, all like kind of mashed into one PhD. So I have one question here. What are the career options apart from academics in plankton research? So if you don't want to go into academics, but you're interested in plankton, let me tell you, there are plenty of options out there. You just have to look for them. Think about algal work. So a lot of a lot of oil companies and a lot of biodiesel work in research and development and R&D is being done with plankton. So if you are interested at all in research and development for alternative fuel options, or figuring out how to work through a lot of phytoplankton work, they specifically target the lipids in different phytoplankton, and they will use different extraction methods to get those lipids out and to use them for alternative fuels. So that's an upcoming market. So if you're interested in that. There's also a lot of work in cosmetics. So if you're interested in research and development, when you're thinking about how you can maybe use a different chemical component to plankton research, that's there as well. There are a few labs in the United States and internationally that will actually be algal culturing labs. They're not as common. There are a few here. I think there's a few in France. There's one in France, maybe one in Italy as well. I know that there is one in Japan. I can probably find the rest. I know I have a list somewhere. If you're interested in actually culturing the algae, which is what I do. I culture algae. So I go out, collect the algae, and I bring it back, and I culture it. So I spend, that's a great question. So do I spend most of my time in the field or in the lab? I would say at this stage of my career, I spend the majority of it in lab, but maybe like a year ago, I was spending a lot of time on boats and collecting data and on ships. So I would say it kind of depends on what you're interested in. Right now I'm trying desperately to finish my PhD, so I'm spending a lot of time writing and in the lab. But earlier on, a year or two ago, I spent a lot of time in the field. Actually, this sweater, I guess, the sweater that I'm wearing is from one of the cruises that I went on for 36 days in the Gulf of Mexico. So it just kind of depends on where you are in your career. I know that I can't spend all of my time inside. It would drive me crazy to stare at a computer screen for the rest of my life. So there has to be some kind of outdoor field component to whatever my next step is outside of my PhD when I finish. So if you're interested at all in algal work or plankton science, you are not limited to academics at all. You just have to kind of know what to search for when you're looking for positions, and especially if you're interested in toxins and looking at toxic levels. So if you are interested at all in biochemistry or usually biochemistry is like the bigger topic with toxins. If you're interested at all in that, every region or every state has a water testing lab. And when you are testing water, you are testing the different toxins and the different species of plankton that produce those toxins. So definitely look into those three options that I provided if you're interested at all in plankton research, which I'm sure all of you are, because plankton's the best. So definitely check those out. Did you develop seasickness due to travel? I don't know what happened to me, but I get seasick all the time when I'm on a ship. I don't know what happened. I wasn't seasick at all, and then I graduated college, and all of a sudden I'm seasick all the time. So who knows what happened to me, but the data is still collected even if I am incredibly nauseous. So if you get nauseous, if you're seasick, do not worry. You can still be a marine scientist, I assure you. I've gotten this far in my life with seasickness, and it's fine. It's no problem. You just work through it. Okay, let's see what else. So I have 4 questions here that are really not exactly related, but they're really good questions. So the first question is, what taxa give you the most troubles to identify? All of them? I'm going to say, so I have this taxa guide here that was made by the people in my lab, and they're amazing. And I'm going to say, yeah, they're all, I dabble in taxonomy. I have to as a plankton ecologist, but I'm going to say Nietzsche, which is this diatom right here, which contaminates everything. So I'm going to say Nietzsche is always a problem for me because there's another organism that looks exactly like it, Salingatheca, and it's awful. I would also say that smaller plankton, so picoplankton and nanoplankton. So those are the nanoplankton is the 2 to 20 micron size, and the picoplankton are smaller than 2. Those are really hard to identify because they're so tiny, so you can't really use light microscopy to identify them. Which kind of brings me into my next question that I got a lot. I had 4 of these questions, which what microscope do you use, and what is the brand, and how do you use it? So I will be totally transparent with you guys. I have been really lucky at each lab that I've worked in to work with amazing microscopes. And I mean like $60,000, like $100,000 microscopes, like really. It is the PIs, it's the primary investigators that have provided these microscopes. These are not microscopes that I have in my living room. These are microscopes that are really specialized for what we do. So right now I'm working with an Olympus microscope, and I work specifically under DIC, which is a setting, and it essentially looks to kind of remove the halo that happens a lot with diatoms, because if you remember, these phytoplankton, not these phytoplankton here, a lot of them are diatoms, so they're made out of glass, they're made out of silica, and when you use DIC, it kind of removes the halo around the individual cell to give you a crisper, sharper edge. So a lot of times the images that you see on my account, those are taken with the Olympus microscope under DIC. And there are amazing people out there that talk a lot about the different microscope filters that you can make from scratch that you don't have to spend $3,000 or $5,000 on. They literally just make them from scratch from different types of film, and they're able to achieve the same pictures. So if you just Google that, you can find alternative methods like DIY, like a DIC filter. So there are options there. You just have to look for them. It's taken me a little bit of time to get to where I am with microscope photography. I started in 2011, and I've been doing it, probably on and off since then. I started again in 2015 for my PhD and really got into it in 2016, where I pretty much do it every day. And it's helped a lot with the taxonomy. So if you are interested, whether it be a bacterial cell and you're interested in the medical field, or if you're interested in being a plankton scientist, it doesn't matter. Like, use the microscope. Like, learn the ins and outs, and each microscope is different. So you have to learn to play with the light. The images that you see, I'm going to say 80% of it is understanding the light. So understanding how this like what is the organism made out of, and knowing where you want the light to hit the organism. That's the best piece of advice I can give you. I got that question a lot about the microscope because I think people are starting to see microscopes that attach, or lenses that attach to your phone, and they're wondering why the images aren't translating as well from what they're seeing versus what is actually happening on their phone. And there are a lot of options out there. There's some great options on Amazon and a few other sources if you are interested in kind of doing like a travel microscope. I do have that. I don't usually use it too often. I normally just check to see what's there, and that's how I use, that's kind of the main purpose of why I use the microscope attaching to the phone. Not so much for photography, but it's a great resource. And if you just kind of play with your filters and you play with the light, you can get some really nice images. So if you have any more questions about that, you can feel free to put them down here or just message me privately. I'd be happy to answer them. So the last question I got was about Plankton programs for those of you that are interested in doing a PhD or a master's program in oceanography. I'm a biological oceanographer, so if you're interested at all in those programs, and I also got asked about specifically with plankton for international. So my piece of advice is I don't know the names of the different people to contact for a lot of the universities, but I do know how best to search for them. All marine science programs are going to have someone that studies plankton. It's nearly impossible not to. So it's going to be your job as the student, or your job, to go and search within the faculty, within the list of faculty, and find probably the 2 or 3 people that study plankton. They may study bacterioplankton, they may study the picoplankton that I mentioned earlier, they may study plankton toxicity in freshwater systems or marine systems. They may study community analysis in regards to fisheries. But there's always going to be someone that studies plankton in all marine science programs because of what I mentioned earlier. Plankton are the base of the food web. So if you are trying to answer questions on whales, if you're trying to answer questions on sharks, you have to first understand how stable your ecosystem is. And how you do that is by looking at the plankton and looking at the health of the environment. So you're always going to have that plankton scientist there. I'd be tremendously surprised if there's ever a marine science program, international or nationally, that does not have at least one plankton scientist on staff. So look them up, go to the faculty page, read the different bios, and see who's there. Shoot them an email, be very polite, be professional. Do not use, abbreviations. Like, write out a very professional email, keep it short, and send it to them. Professors are very busy, so the likelihood of them responding is not 100%. So don't be offended if you send out 5 emails and only 2 come back and respond to you. That's normal. But send them an email, express your interest, and kind of go from there. That's how I found my current advisor. I sent her an email about a paper that she wrote, and there was an opening in her lab, and so that's how we started our conversation. Okay, so any other questions about that? I have one question here. Yeah, I will provide, so it says, can you please provide the link? I absolutely will, and I will share it, and it'll be great. I have a few. I have one that attaches to the phone, the one that I use like just for field work, because my phone can at least give me an idea of what's there. It's not, it's not a huge thing. It's just one of those clips. And then the other thing that I use is I have a small travel microscope that I use, and then I also have like the larger lab ones. So I will give you all 3 of them, and you guys can look them up. They do vary in price. I'll tell you right now, the one on my phone is super cheap. I think it was $6 or $10 or something like that. It was and it's great. It does exactly what it's supposed to do. It gives me a quick ID of who's there. Are they ciliates? Are they diatoms? Is it mostly zooplankton, or is it mostly larval fish? So it gives me a really quick idea of who is in the system. So it's perfect. Let's see. Do I have a favorite diatom? Right now, it changes. Right now, I love Odentella. Odentella is the organism that I will show you a picture. It's the diatom that I originally isolated my thesis organism on. So this is what Odentella looks like. This guy. And my thesis is based on Nano Flageolets, and Nano Flageolets, I'm going to draw it. They are small organisms. They're less than 20 microns, and they attach like this to the Odentella, to the diatom, and that was essentially my thesis is looking at this nanoflagellate and why it's attaching and what it is, and it's a new species of plankton. So the first part of my thesis is based on one plankton attached to another plankton and looking at its taxonomy. So you never know what you're going to find. A lot of contamination. So you never know. What else is up here? I know I had other ones. I can't see. Okay, so why can't all international communities ban plastic? Oh, that's a great question. I don't know why they can't ban plastic. I wish that they could. That would be amazing. It would serve the marine system quite well. I don't know, to be honest. I think it's a pretty big ask. I think that there's a lot of money in plastics and in oil, and unfortunately that's kind of what a lot of people aim to serve, is where the money's coming in from. So I don't know. I think the best thing to do is just speak to your local politician. I went to DC a few months ago, and I met with a lot of members, staffers on the Hill, both on the Senate and on the House side, about climate change. And I will say that it was really productive. Feeling that you want to go and talk to your local representative, please do so. And you never know what conversations are going to come from it. So that's probably the best piece of advice that I just learned about, because I was very intimidated for a long time about going to DC or even meeting with these people. I mean, they're not scientists, the majority of them. And so having plastics, about ocean acidification, about climate change, especially on a small level, with plankton versus, I don't study whales, so it's had a really big impact. So you think that you are capable of doing. So we have 2 more questions. How can we reduce ocean pollution apart from dumping processes for ocean cleaning? So I'm going to answer this in 2 parts. So how can we reduce it is just simply by recycling and reusing. So easier said than done with a lot of our products, but I think that just being aware, solutions out there. So instead of using a plastic toothbrush, when my in that, I will be switching over to the bamboo toothbrush that just came out, I think, last year. So just kind of being aware of the waste that we as individuals are producing on a daily basis, I think is probably one of the largest ways, because it starts with you. Small changes is going to help the marine system on a larger scale. If all of us cared and produce just a little bit less waste, think about that on a global scale. let's see, tell us more about ocean acidification. I talked a little bit about that, especially in regards to, I'll show it again, especially in regards to the coccolithophores, which are the, let's see if you guys can see them here. The bloom-producing plankton, and you guys can actually see it from space. And these have calcium carbonate shells, and so because as the pH of the ocean shifts, that's going to have an for these organisms to produce their shells. The marine system over time. Just if I take marine bio as a master's degree only. Okay, so that's a really good question for anyone that's interested in marine science on like a global. Say that my undergraduate was in biology. My minor was in psychology because I was very interested in behavior, and I still am very interested in the behavior of organisms. And so I never took or never specialized in marine biology as an undergraduate. I got a lot of experience in the field. I've been doing school, so I got my experience in marine biology in different ways. So outside of the classroom is where I got my experience. I was in biology, and I specialized, and I did work again in marine ecology, and that's where led me to my PhD. So I think it's less important on the grander scheme about what classes you take. Like, yes, it's important to take basic statistics, it's important to take chemistry, basic biology, you know, the basic course load so that you understand the larger scope. But for marine science, you have to be in the field. The biggest piece of advice I can give kind of anyone is please go get an internship or a part-time job or think you can financially handle, and go get a marine science experience. Nothing speaks louder on a resume than spending 2 months on a ship collecting data. That means that you are capable of collecting good science, that people trust you, that you are able to spend time at sea and learn new methods of data collection. So resumes in my hand, and one resume only had coursework but person had a little bit of coursework but had always. It's really important. So if you're interested in marine science on any 16 years old and you're in high school, go. And then I'll also tell you where you fall. Not everyone is going to want to study chemistry or geology. There are a lot of different components to marine science. You know, plankton have a huge role in cloud formation. So there are scientists that are atmospheric scientists that study plankton but apply it to cloud formation. I mean, that's a link. There are people that specialize in marine at plankton that way. Physical chemistry is the same. My department is a physical oceanographer. A little bit of chemistry and a little bit of biology for her thesis, and she looks at hurricanes and how they impact plankton populations, and so she studies the physical movement of ocean blooms that form afterwards. So there are a lot of there is even my advisor got a grant with I I don't remember who it was. I don't know if it was a neuroscientist or along that realm, but plankton, some species produce toxin, and that toxin can aerosolize and go into the air, and we inhale it, and that's different components of our body physiology on a physical level. So there are a lot of different ways to incorporate plankton science into what you're going to be able to understand. What fascinates you and what gets you excited about science is if you get that experience. So I'm done preaching, but please, if you have an experience, try out an internship, do whatever you can to. Science is something that makes you really excited on it. So I just want to show you guys here. As a PhD student, I don't do a ton of reading. I just wanted to kind of me find my path, and let me just show you. I have a few. Michael Pollan is amazing. This was probably one of my first books to take with me out into the field. I went to Salve Regina University in Newport, Rhode Island. Capstone had us read a few really impactful books. One of them was Guns, Germs, and Steel, and then this one is really awesome. If you're interested in understanding your impact and your carbon footprint, you know, your place kind of as a carbon-based organism in the world, this is a really good book to kind of start with. He does a really nice job talking about the impact food has on ecosystems and on ourselves. So this is another awesome book. Oh yeah, this is Michael Pollan, guys. This is another one. This is by Dr. King, and How Animals Grieve. Interested in behavior, and this is a map about cats, chimps. This is not plankton, so just keep that in mind. But this is a really powerful book. Some behavior. It's a really introduction to a different side of behavior. A lot of times when we think of mating, right? We think of how organisms mate and sexual selection, how they eat. You know, this is a different lens into organism behavior. So this is a really good one. I highly recommend. It's sad. You read it, but it's really good. And this is a book that one of my best 4 years ago. So Amanda gave this to me. It's American Women, and 6 conservation are kind of keystone history of the United States. And of course you have people like Rachel here, and it's just a really nice, easy read of just about, you know, females in science. If you're interested in this, it's and then this is one of the books. If you're interested in evolution, if you're interested in to start, this is a course book, but I know the author. awesome. He was at Yale when I was there, and I worked right next door to him down the same hall. And he's a great guy. He's an amazing person. This also is a really good book too. To kind of begin your conversation on an academic level with evolution, with terrestrial and marine theory, this is a good place to start. So a little bit more marine. Dr. Wilcox is really good. This talks about her work with cnidarians, so with jellyfish specifically. Between and what it means both on an immune system level for different organisms, also conceptions a little bit surrounding by some of the world's deadliest organisms and their reputation. So I definitely recommend this book as well. She's also really nice. And then 2 books a few times, but I promise I will read. Curious Life. I did a book swap with a fellow marine scientist on Instagram, and we just did a book swap. So I gave her a book about rats on islands and how they're destroying, not exactly positive, or like, I gave her a book on rats on this. So The Curious Life of Krill, so far it's very good. It talks about the difference of different types of krill, their importance in polar ecosystems, and also a lot of misconceptions about krill. Realize I've never been to on my to-do list, but I've never been there. And I didn't realize how large krill were. And I always thought that they were really, really tiny. But no, they're large. Conversation of whether or not they fall into the plankton category of not being things like that. So it's a good book. I recommend it. So on my to-do list. I don't know if you guys have you guys read this or not, but this came out in 2012. It's from Bill Nye, and he signed it for me. Celebrating Science. So it's really cool. Really excited to read this as well. I have been meaning to, but I just have not gotten to it. So those are some recommendations. Some marine books, some academic books, some non. So I hope you guys are able to kind of branch out. So if you guys want me to give you a list of some of these, I can. Curious Life of Krill was probably one of the best ones. So I can make that available here. I only have one more question on my list, but if you guys have any questions, to write them. We have Off Topic. Are you excited for Game of Thrones Season 8? Yes. Excited. I can't wait. It's going to be awesome. Exciting, happy episode. Let's see. I've read a huge role in making O2 in the earth and started then can we take them to, say, Mars or the moon to increase the O2 there? So that is a question I can partially answer. I don't know about taking them off planet. Cyanobacteria are plankton, and you can find them in the ocean. There are images of them form large colonies on my page on March of the Plankton. So I definitely recommend that you go over there and kind of get an idea of what cyanobacteria. But yes, the first life on Earth was plankton. It started in the ocean, what we now know is the ocean, and did a huge amount to the oxygen in our atmosphere. So it really, my advisor says, and I think I'm steal it from, thank a teacher. If you can breathe, thank a plankton. And I kind of stand by that. They're tiny but mighty. The plankton do an amazing job. So yeah, so that's the answer to that. About off to Mars or the moon. So yeah, any other questions? I see I asked a long question before. Can you repeat what that long question was? I think I might have missed it. Or no, I think I got it. I think that was the moon thing. Okay, any other questions? Before I log off here? No? Okay. So, I'm going to get you some travel microscope links of some things that I've worked with before that are good options. I'm all of just some easy reads if you're interested in ecology work or just those are, so I'm going to get you guys those. And my last question that I had from my account, someone asked me, even though plankton are small and we can't see them, is there, and I think that's a really up with of just some personal impact. So even though plankton are tiny, there's plenty that we can do to protect them. And I think the biggest thing that we can do is just that we're using, how we're throwing it away, putting into the ocean, because it's going to impact the plankton. So things like oil spills, high turbidity, and people and machines kicking up sand, that essentially blocks out the sunlight and kills a lot of the plankton. Putting in fertilizers on our grasses and having that wash into the ocean is so being a little bit more self-aware and reminding like our neighbors or reminding my parents, your parents, or my parents were tired of hearing about it, reminding your parents, instead of throwing all this plastic away, we can use glass or things like that. About, it all goes back to the ocean. Even if it's being washed in that river is eventually most likely going to lead to a lake or to an ocean. It's going to lead somewhere. So that was one of my last questions. So thank you guys so much for me this morning, this early Sunday morning. I really appreciate it. And if you have any follow-up questions on about marine or about grad school, please feel free to reach out. I respond to my messages. I try to get to them daily. So please reach out to me and I will do my best to answer them the best I can. And if I can't answer them, I will direct you to someone that can. So thank you again. I really appreciate it. And enjoy the Game of Thrones. Bye guys.